Welcome to another Hacking Finance podcast with myself, David Galbraith, and Sean Park, founder of Anthemis. This time I was thinking, Sean, given what's been happening really with the experimentation with AI models for imaging, like Stable Diffusion, that really are game-changing in terms of demonstrating to people the power of what these things can do, but I think actually open up some new opportunities for user interfaces that are really haven't happened in decades in computing. I thought we could maybe talk about the broader impact of what it means to work, what the opportunities are in software and in products for working either with machine learning, where you have a prompt and it can make an image, or no code or low code platforms that try and do the same, but often with a very different approach on highly structured data, in the sense that, you know, working with numbers and invoices and the things that we come across in fintech, you can't make mistakes and you can't be fuzzy. Whereas the nature of what's happening with a lot of machine learning tools is the outputs are somewhat fuzzy, to the extent that if you hit the same button with the same prompt the second time, you get a different result. And so really, what does this mean for the sort of sector we work in, which is largely based on structured things that you want a very high level of accuracy, which is why people got obsessed with blockchains and things like that. Versus the obvious advancements that we're seeing in machine learning at the moment.
I mean, that last point you made about, you know, getting a different result with the same inputs and pressing the button, I think, you know, it's fascinating. It's like AI replicating middle management, where you just keep doing the same thing and pressing the button until you get the answer you want in a big company. I'm not sure that's exactly what you were alluding to, but no, I think it's fascinating, and it's been interesting. We were talking about this earlier, like our friend and partner Yan, who has certainly gone down the Stable Diffusion rabbit hole in the last couple of days. I was sort of thinking I could just see him at like 3 in the morning, and Barbara saying, "What are you doing? Come to bed!" and just entering prompts and pressing go. But it's. I think it's timely. I mean, I saw you did a really interesting tweet thread or whatever they're called. I think earlier today or yesterday, which, you know, catalyzed this discussion in the sense that we're at I don't know exactly what stage, very the earliest stages, but discussion I think that's interesting is not so much, well, that's interesting too, but for different reasons. But maybe for this audience, for us, and what's germane for what we're trying to do at Anthemis and with the people and the companies that we back, is it's potentially going to change. I was going to say development paradigm, but it's actually not that. It's like the value creation paradigm, which I don't know if that's the right sort of shorthand, but I was trying to generalize to, you know, how do you build a company? How do you build a product? How do you make it better, which is sort of the gist of quote unquote technology startups and investing as a broad-based sort of shorthand for everything that we do. And just an aside, has become like, who was I talking to the other day? It's sort of like a frog boiling apart. It's now a very big part of like the economy, not necessarily percentage wise, but it's like, it's a given that that's how you create, you know, new business models, new value propositions. It's sort of this venture model. And if you go back 20 years or even 10 years, but certainly 20 or 25 years, that was not at all the case, or only in very specific, small sort of niches. But anyways, to come back to the topic at hand, you know, it might be, I actually think it's a bigger one, but I was trying to think of, I always like to think of these sort of, use Carlotta's thought frameworks, these, okay, you know, technological revolutions that catalyze a paradigm shift. And the last one, which I think is actually smaller potentially than this one, but that sort of seems to me to punctuate this, was the move from like a client server in on premise to cloud. And that sparked a whole like, oh my goodness, you know, you can the lean startup and all the rest of it. And there's a lot of noise around that narrative, but it was a fundamental transition. Whereas before that, you know, putting lean startup rhetoric aside, when you raise money to build a company, a tech company in the 90s, you had to raise a lot of money just to like reinvent the wheel and build your infrastructure stack. And obviously that changed with the cloud and maybe mobile, and those were fairly contemporaneous, although they're different things. But this is potentially the same thing. Whereas, you know, if the paradigm now for the last, I don't know, what is that, 15 years or so has been, okay, you take a cloud infrastructure, you take a bunch of like ubiquitous cloud services as you know, the foundation of whatever you're going to build on top of that, and then you start coding and start building product. Maybe going forward, there's, you know, this becomes a key layer. This being, you know, machine learning, AI, things like, or the equivalents of stable diffusion or GPT-3 or whatever, where you just start typing your value proposition into a machine and see what comes up, and doing that several times. And you know, and then I guess that's where human judgment and intuition, you know, hopefully stays just a little bit ahead of what machine learning is, or whereas you're curating, okay, what comes out of this. And then there's a whole bunch of questions that maybe we can get into some of them today about, you know, how much of a black box is that? Does it matter? You know, do economic models change? Is there like no barriers to entry? And so, you know, that was the insight that I thought was fascinating that you surfaced, which is, you know, today it's all about, you know, images and text with GPT-3, which are big, you know, things on their own, but you know, it doesn't take a giant leap of the imagination to, you know, move beyond those use cases and imagine a world where, where you don't, you know, you don't need to, you know, like, just like you no longer need to buy a whole bunch of servers from Sun or whoever it was you were buying them from, and a bunch of backend sysadmins like in-house. You know, maybe you no longer need to hire or a bunch of, you know, software developers or fewer or different kinds.
Yeah, maybe we can unpack. So I think what would be good to talk about is, one, that back-end proposition, why the relationship between where the smarts are and what's coded and how it's developed. I think that's one aspect. To clarify the one that I thought was more mundane at first, and then I thought, as I started playing around with stable diffusion, that suddenly sort of occurred to me why I thought this was such a profound shift. The hypothesis is, so I played around with it, and what I did was I tried to look at really quite obscure styles in architecture, because obviously having been an architect, I knew some quite obscure architect, and tried to get it to design drawings or buildings or designs from these obscure architects for specific projects. And they were alarmingly good. I mean, really, really obscure stuff. And so, you know, the inputs of these are several billion images. But what it led me down was realizing that there's creativity, if you like, in deciding what to put in this box that just says type anything into it and it'll do something. And getting it to do good things requires a lot of creativity. But if you look at then the things you can do with it, which are very simple, let's say, like, say, remove the sky from this image. In the old days in Photoshop, that required drawing a mask around something and lassoing it and configuring a whole thing, and having these commands that very much were fixed and about how you manipulated a bitmap. And so when you just say remove the sky, this is a semantic command. And that's why I've used the term semantic UI to say that this is different. And if you imagine Photoshop, where people then can also discover these semantic commands like shrink, resize, they're not preset. So unlike a shipped piece of software, which is a very fixed set of menus and hierarchies, this is a really different way of interacting with something, where you could imagine that the interface, the commands, would be part of a community of people who would invent new and wonderful things you could do, not through plugins, but just through literally saying, these are the instructions you can give this thing. And so you can imagine that there is no then fixed interface, that it's a community-driven effort to derive what the things you can do with this product are. And to my mind, that then means that you're in a completely different way of interacting with a piece of software that's as different as it was when we went from the command line to Windows. And the Windows operating system was built on top of the command line ones, was certainly, ironically, the later ones were. So this could be built on top of it, but you could consider this to be potentially a new operating system. And that to think that Stable Diffusion ends up as a Photoshop plugin is not the right way to look at it. It's like Photoshop goes away and there are new types of software. And not only are there new types of software, the whole way we interact with things means that the things you can do with it are part of a community effort, if you like. And so that's a very different way of interacting with software.
Yeah. I mean, that's sort of exciting. Even you just take which is a very narrow use case, but the case of manipulating images, there was a whole craft that you had to learn to use these tools, whether it was Photoshop or other tools. I'm sure there's, in order to, convey. And so that energy barrier, that bar to instantiating that creativity is very, very high. So, for instance, you or I or anybody might say, oh, I'd love to, I need this image for, I don't know, an event I'm doing or a t-shirt or just because I want it. But, I think anyone that's listening, I'm speaking from personal experience, has experienced like going from zero and having to learn and fiddle around with whatever piece of image processing software to create masks and lasso, like you said. It's entirely doable, but it again, the analogy of like, okay, I have to learn how to, spin up a server, right? That's probably eminently learnable, but like, why on earth? Like, it's a huge energy barrier. Unless
Exactly.
your need is so huge, are you going to do that? And here it just like drops, that energy barrier drops to zero.
And that's exactly what the command line did. Like in the old days, you had to learn all the commands. You had to sit in front of a Unix prompt and know the universe of things you could do.
Yeah.
And then what a Windows interface did was it was event driven, so it allowed you to discover things. Yeah. This allows you to not only discover the finite universe of things that the programmer has allowed you to do, but it allows you to discover new things.
Yeah.
And that's why I think it's a step change. And I think therefore it warrants us talking about whether this will result in a new operating system around it, because we haven't had a new operating system for nearly 40 years.
And what do you think that might look like? Do you think it'll be more like and I don't even know, these metaphors or these analogies are maybe not even germane, but like that's how our brains think. Is it like more Linux-like in terms of open source, or is it a proprietary like iOS or OS?
I think it's more, it's more, I mean, dare I say it, I always hated chatbots, but it is more like that sort of paradigm of, well, there's just there is no interface. You just interact with this thing. You ask it to do it, it does it.
Yeah.
And getting back to that, why I didn't like chatbots was, and I didn't like no code or low code tools, is that if you ask these AI models, because they produce a different result every time, if you say pay all the invoices and it does it differently every time, obviously that's a disaster.
Or maybe not.
Yeah, an interesting creative way. But these low code, no code tools are trying to do these highly structured things, and they seem to be, therefore, when I look at the interfaces, they're actually always trying to do things visually that sometimes are just better done through command line, actually through programming. And so you wonder what the benefit is, given that underneath these so-called low code things, they actually produce more code. So they're low code.
Yeah, I think that's right.
Yeah.
I mean, I think that we were talking about this before, but what's exciting, the idea has merit, right? And a lot of people have got behind it. It's the next big thing, and there's probably been a lot of money invested. But I always struggle to get excited about for exactly that. And me being a probably for once in my life a potentially ideal user for that, because I'm interested in technology and I'm sort of it's germane, but I'm not a coder, and so I have the desire, but not the skills. And anytime I've tried to use and any, and I'm sure there's some that are better or worse, and maybe I was on the unlucky end of worse, but it was almost, you had to learn to code. It was just easier in terms of, it was like, English, or, it was sort of natural language, but it was still coding, or visual, combination of that and visual. And so I guess that's easier than, at least as a initial barrier, it's sort of easier than having to go learn a coding language, or some simple commands, but not that much. And it was so constraining, right? So you could do, like, if you had, it was, and so and immediately, if you want to get in complexity, my understanding, it was usually doable, not even universally, but usually. So it wasn't, in fact, it wasn't doable, but you had to learn as much. You might as well go and learn, Java or Python or whatever.
Totally agree.
And
in some ways, there's a zen to using those things. Whereas, I mean, my kids have used Scratch and some of these visual tools, but there's a point where all you're doing in all of programming is just basically if this, then that, and variants of it. And so you might as well do that in a command line. And there's a point where you,
So I think it might be, if there's a utility to the whole no code movement, and the money was invested, like at least from a societal point of view, not going to waste it. Maybe it's a little bit like a dead end on an evolutionary tree. So the intent is interesting and germane, but the execution thereof is like, it's going to peter out. And this new generation of tools like Simple Diffusion, GPT-3, and I'm sure hundreds more that will come, that's the real no code. And a question I had that I don't know, I think I know the answer to, but I want to educate myself. I think you probably know more. Is, does this make sense? If that is true, in that world, though, everything becomes, all our devices, the one I'm using here, or phone, whatever, it's more like a Chrome. Everything is in the cloud, because you cannot run, like, so if that's an operating system, even if we're using that language, it can't run on the client because it's
so weirdly it
too huge. Or can it? Or how do you see that develop?
So that's what's amazing about these machine learning models, is they're tiny. So I mean, Stable Diffusion, I can't remember. Let's say they had 3 billion images, or it was billions, but for the sake of argument, let's say they had 3 billion images training it. The end result will fit on a thumb drive. I mean, the model itself is a few gigabytes. So,
but doesn't it need to access the training set, or no?
No, you can run it on the client. I mean, it's a series of parameters. They are bizarre, these things. The series of parameters, the parameter space is bizarrely compact. I've never really understood why they're so compact, but these things can run to a large extent locally. Now, whether you can update them, like you say, and whether they have to reference the original training set at some point, that then obviously it has to be cloud-based. But I'm not so sure it necessarily means thin client, is what I'm saying.
Okay. Well, where I was going with that a little bit was more in terms of, when we look at, we talk about this a lot, when we look at like paradigm shifts, bigger or small, and this is a potentially bigger one, but there's like tipping points in this necessary but not sufficient conditions. And I was sort of thinking, one of the necessary conditions is actually, we live in a world where, even though I could disconnect, well, we would no longer be talking, but I could disconnect this laptop and still do lots of things on my client. The reality is, whether it's for work or for personal whatever, and anyone who now goes into a dead spot where there's no Wi-Fi or no mobile connectivity, it's just it doesn't work anymore. So the where I was going with is that, like, over the last 10 years, the way that we as humans interact with technology have evolved to the point where the de facto base state is a cloud-based, like, we actually need to be connected. Whereas, let's say, just as a thought experiment, this had been invented 10 years ago, and I'm talking more from a zeitgeist and the cultural use of technology, not the technology itself, but you have to be connected for it to have real value. That would have been much more limiting to today, where connectivity is essentially taken for granted and ubiquitous, irrespective of whether you're using giant cloud-based machine learning programs or not.
I think some of the more interesting use cases for machine learning certainly are where it's not connected. Like, I know that that little camera that Google did a while back, which had I think it was a Morpheus chip in it. So it was all client side. So the models were embedded in it, and you could. So for things like, for two use cases, one where there was a privacy concern where you wanted to manipulate and get an answer locally without having to go to the cloud for image recognition, things like that. That becomes very interesting. Or the other one that's super interesting, just where the latency is like an impossible thing to solve.
Yeah.
Where you want super reactive sensors, like for a lot of the self-drive stuff, where you can imagine a lot of like true, the kind of self-drive that we're hoping will happen, where you can climb into a car after 5 pints of lager.
I guess. So the other vector, this client server cloud, but the other vector is just pure technology. And again, a bit ignorant here, but my understanding is you need a lot of RAM. So okay, maybe you can run it on a client, but you need a lot of RAM. And so and it's even depending on how it's sort of pushing the limits even today of like the average, or you have to have a souped up relatively new laptop or whatever.
But you can imagine that becomes something that is available in a car. Like a car will need to run local operating system of sufficient power to deal with the
although I don't know if this is just I do worry a little bit about the compute and storage power. We went through a whole phase where compute and storage sort of went to zero as in terms of costs and the way that changed. I remember JP Ramaswamy, I thought was like a brilliant, gave me an epiphany 20 years ago when he said, okay, we're moving from a world of scarcity to abundance, and talking about lots of things, but particularly talking about compute. And it wasn't that it was like an order of magnitude cheaper, which is good. You can do lots of things, but if it goes to sort of zero or quasi-zero, like it just changes the way you think about the world completely, and the way that you write software and the way that you build businesses, etc. And I'm just wondering, that actually zero, and this is germane to what's going on with climate, what's going on with energy markets, how energy voracious is this future that we're talking about a new, if this is the future, let's just do a little science fiction,
I mean, that's something we talked about before, but certainly my belief is that to solve climate change, we need to understand complex adaptive systems. We know that at the moment the only way we can do that is through brute force. So my view is that we are going to need massive amounts of compute power and massive energy consumption, ironically, to solve our issues.
So that makes sense, but then you need to plan for that. And I'm not sure, like it'd be interesting to see, and again, I'm going to sound a little bit cynical or even maybe patronizing, but the sort of the powers that be that can affect sort of change or planning on that sort of level, humanity level scale, like, wow, they're so far behind. So let's say this takes off, and let's say, in the same sort of timeframes as what we're like mobile or cloud, or like in terms of a paradigm shift, 10 years from now, this is how the world works, and this is the new operating system and all. Like, I don't know that we can, so I would agree with you that in the longer term, we have to go through that, but also, I think of it in terms of like liquidity in markets or in gambling, like if you double down all the time, you eventually win, as long as you can stay liquid enough, right? And that, as long as you can stay liquid and suffer the drawdowns, or is actually the only important part of that sentence, because usually you can't. So, if there's a world where in 10 years time, 50% of the energy demand is, or more, maybe, I don't know. It'd be interesting to sort of, I'm sure some people have started to model this, even if ultimately from a path dependency point of view, that is the way to solve it, that would put enormous stress. I don't see our energy infrastructure changing fast enough to like.
But I think those, I like those kind of constraints, because we know that EVs have contributed to blackouts in California at the moment, and they require an upgrade for the electricity grid. And as we upgrade the electricity grid, we then are less reliant on things like coal and things like that. So
No, but that's what I'm
these things
like.
benefit,
We're
like,
agreeing in terms of the
yeah,
long term, but you still have to like so to take that example, so there's a couple blackouts in California, survivable maybe now, but like those like localized, short term until we fix the infrastructure problems are going to get more and more severe, and then it becomes a point like the person gambling at the table of Las Vegas, where it doesn't matter, even if you had like an oracle and you knew you would win the
yeah.
next hand, sort of thing. You don't have a million billion $1 trillion to continue playing and see game over.
I'm optimistic about the energy use of computers, because I think it can be made very green, and we can locate them in places that are, and they can help solve the issues they create. So the thing I'm less optimistic about is the fact that, as we mentioned, that low code products create lots of code underneath because they abstract things at a very high level.
Yeah.
That machine learning models, we have no idea how nothing is codified. So we don't even know what the logic is underlying it. So the technical debt they create, I think, is a bit like that thing that, what was it, about derivatives being weapons of mass financial destruction.
Yeah.
I think it's possible, might not be true, that machine learning is a weapon of mass technical debt. Like as it solves problems, it creates more problems than it solves, but by virtue of its complexity and the fact that we don't know how it's arriving at solutions. And we don't know. No human being knows how stable diffusion drew a fish riding a bicycle. They just know it does.
Yeah. And so drawing a fish, a very cool, interesting, creative fish riding a bicycle, is a low stakes outcome.
Yeah.
Optimizing nuclear energy, electricity production is a bit scarier, and maybe this kind of software can do it like 100 times better than humans, which would be a huge thing and important, again, especially in that context. But like, are you comfortable, because you have no fucking idea how and if there were to be I guess it's like a debugging problem. So if something were to go wrong, you don't even know where to go to fix. Like, there is nowhere to go to fix it, or to
exactly. So
root cause.
I imagine a future where, in the past, let's say the original sort of American Express system was written in 50K of memory, and that one person could understand the entire system. And now, of course, these things are huge and bloated. And now it's going one step further, that although this is the only way we can probably model some of the complex systems that we need to model, that are like three-body problems. So we will start to understand the natural world and hopefully the weather and things like that. But at the same time, if we're creating this synthetic risk, i.e., we're creating a vulnerability in the thing we're using to solve complex systems, then we're back to square one, where we've actually got
or maybe that's a conservation law of information. Maybe there's like, ignorance is conserved.
Possibly, yes, exactly. That would be terrifying if it's true. Where the more we understand the natural world, the more we've created an unnatural one that we don't understand.
Yeah. So what's that? The first law of whatever. But there might be some merit in that. We need to get some physicists and mathematicians working on that. There might be some merit in that. And actually, it might even be linked to thermodynamics in terms of conservation, because information is heat and what have you. But
there would be
without going down that. Yeah, without going down that rabbit hole, the reason I started thinking about that was the point you were making, was that we've always had to deal with that. So it might just even be a cognitive bias of you and I growing, like our children or grandchildren, whatever. Like we're comfortable. Maybe that's not the right word, but like, que sera, sera. We live with certain uncertainties that are intractable. Like, for instance, predicting the weather to a certain extent, whatever, and like, just like fish in water. Like, we don't even think or worry too much about it, because it just is that's the way it is. And maybe this is just a question of, this will just be a new way it is. Like, it's a different thing that and I don't know. I think the more interesting question then is, and I don't even know if this is knowable, but is that better or worse, or just different, right?
Well, it's certainly worse. Yeah, like the chance that we turn the Earth into Venus is an existential risk that's worth trying to solve. Like, so yes, it might be true that in trying to solve us controlling the weather and reducing climate change creates risks, but we don't really have any option but to say, let's have a go, do it. I mean,
that reminds me of that cartoon where the scientist in it, you can put any technology, biotechnology, nuclear, whatever, oh, it worked. The last words of humanity.
Yeah.
It worked.
So back to the sort of the financial services application. If these things can only model very vague and fuzzy things, maybe financial services.
The most of fun.
Well,
Go ahead.
exactly.
Finish the thought.
I think you were going to preempt what I was going to say. Is that actually, like, when you look at accounting, the mystery of someone coming outside of financial services and confronting with accounting is, well, what if it doesn't add up? And surely, what if it did add up, but it added up for the wrong reasons? And across a company worth 50 billion or whatever, it reduces.
Most of accounting. Yeah. Sorry, all the accountants out there, put your fingers in your ears. La la la. Don't listen to this. It's just like they just make up rules so it does add up, right? So accounting is a lot less deterministic than they like to, present it as. But precisely. I was actually going to say a lot of finance is actually quite fuzzy, right? Maybe paradoxically, or maybe that's like a zinger, because everybody thinks of finance as very deterministic. It's numbers. It's very quantitative, and but actually the interesting stuff is super subjective, and anyone that's worked in the world of capital markets derivatives, like it's all statistical, and whether the tools are correct, and they're always an arms race to get better ones. But Monte Carlo simulations is actually trying it 10,000 times, 1,000,000 times, or whatever, and seeing what it spits out, and sort of settling on what seems to be the most common output. So it would be like using, like your example of like same inputs, and pressing the button 10,000 times and getting 10,000 different pictures.
So maybe, I mean, certainly I remember when we did a genealogy startup, and originally genealogy looks very structured. You do a family tree, it's the most structured thing you can imagine. But then if you look at sophisticated genealogists, they realize, of course, that these things are purely statistical. You build evidence. Eventually, when you go far back, it's just evidence that someone was that individual. Sometimes there are multiple individuals that could have been that person. Or it gets very, very fuzzy. And so as you go further back, these things are purely statistical graphs.
Yeah.
In something that should be. So maybe finance is analogous to this. And if it is, then wouldn't it be great to get rid of all form filling with just statistical? So instead of writing name, last name, date of birth, you just kind of fill in enough information till it's happy it's you. Or you talk to this, you interact with this machine for KYC till it's happy it's you. It asks you a few questions.
Yeah, absolutely. So it's super interesting. Do you remember Dave Herman, who was one of the chiefs, one of the key sort of data scientists and engineers behind some of the early Happy Money algorithm? And Galen Buckwalter, who was the chief head scientist there at the time, and he was one of the co-founding team or early engineers at eHarmony, the dating matchmaking website. And again, it was all about these probabilistic building. So, and one of my favorite lines ever is when we launched the original Happy Money credit score and credit underwriting model, which we actually ran in parallel to more traditional ones, because the capital providers obviously weren't going to trust a new model, but it was way more robust. And now it's like a key part of why Happy Money is so successful. But the board asked one particular board, who I won't name, said, well, the obvious question, is this going to work, right? Is this a good model? And Galen, he said, well, I don't know. Like, obviously we're going to have to see, but I can't, he's a scientist, so I can't say for certain, but what I can say for certain is this problem is at least an order of magnitude, if not 2 order of magnitude, easier than the matching problem in human relationships. And we did a pretty good job at eHarmony. And, I don't know, at the time, maybe it's still true, there's X percentage of marriages in the US and so I feel confident that it'll work. But I think, it's all that that sort of probabilistic and you know, there isn't a answer, there are distributions of answers. And I get excited about this vision that, you know, you've got for the semantic operating system, because it might be the way. And now that I'm thinking about it, maybe it couldn't be any other way. It's actually a necessary condition for this dream, this mini geeky finance obsession I've had for 20 years of, you know, perfect asset liability management. I'm actually, perfect's the wrong word, but like optimized asset liability management at an individual level.
Yeah.
And there is like, that is very, like, canonically, I can say there is not one answer. If you take David Galbraith, you take your cash flows, your balance sheet, there's not a canonical one answer. It's like, this is the right way to do it. There is millions of examples, and there's probably some sort of distribution, not necessarily normal, but there's some sort of distribution of outcomes based on that. And it's iterative, right? Because the minute that, you know, you pick one or you do one thing, 2 minutes later, you know, you've gone to the store and bought a large TV or something. I don't know what, you know, I'm just making stuff up, which you have to run the thing all over again, because that, you know, and the only way that that's practical, it's not only even just the technology, but it's the mindset of the problem with coding, or, you know, the Excel spreadsheet is a metaphor for the way finance is done today, or the way, you know, whether it's in a fancy, very pretty UI or whatever, but it's, you know, it's deterministic to probabilistic, sort of like Newtonian to quantum physics. It is through this kind of approach, which is to say, you know, anyhow, sorry, the rabbit hole too. So coming back to Dave Herman, we talked a lot about at that time, because one of the key problems, and still today, for any financial services institution was KYC, right? And identity theft, and like everything to do with identity. And the hypothesis that we had, which I think we actually agreed at the time was robust, but there's all sorts of regulatory and technical impediments to actually turning a theory into reality. And probably that's still true today, but was this idea that any of us, because of our online footprint, and certainly in developed markets, and maybe now like even everywhere in the world almost, but like certainly in any developed market, we have like a footprint that is unique. There is no, you know, there's no way that you can, and sort of the territory is the map, right? And with enough compute power, now there's all sorts of privacy issues with that. Like, this is why it doesn't, like, practically, like we really brainstormed around, could we build a product around this? And, you know, just fell down in terms of, and for good reason. Like, I'm not saying this is like, oh my God, these stupid privacy regulations or whatever, but this idea that you didn't need to have me or you submit anything or whatever, like a machine could tell it was me versus somebody trying to pretend to be me. It's just physically impossible to replicate exactly, you know, who I am. So
I'm convinced that the way you make computers feel human is you get rid of forms, you get rid of bureaucracy. But bureaucracy is the most inhuman, appalling kind of experience, particularly when you get stuck in that, where you feel it's. And it should be flexible to eliminate bias in AI, for example. Like, you should be able to get a different answer. Like when you got no, you should be able to get yes if you. And so KYC, as you say, should be a formless experience. It should, you know, if you go and you meet someone that you know, they just accept it's you. They don't ask you to fill in a form with all your details to verify it's you. And so this is how humane financial services should be. And I can imagine we could get rid of a large portion of the world's bureaucracy if we ironically say it doesn't matter if you get a different answer each time. That what you're trying to achieve with form filling it is bogus. You're trying to enforce structure where it's not needed. And it's an obsession from the industrial age, where bureaucracy became so industrial and so mechanical.
It's a descendant of the sort of Taylorian, you know, scientific management. And I think we're at a point where, but it's going to be hard, because I think it's cognitive. It's still today, I don't know, I hazard a guess, but I would say, you know, I don't know, there's some tiny percentage of the people that sort of grok quantum, the implications of quantum physics versus Newtonian. People love deterministic, and I'll include myself in that. Like, I think I do understand that, but like, maybe there's something in the way our brains are wired, you know, and so to let go, to your point, which I think is a valid point, but the cultural or sort of cognitive ability to let go and say it's okay, even when manifestly the outcomes are supporting that conclusion, that could be challenging, I think. Or maybe it's
I think you're exactly right.
It might be a generational thing too, right?
People will hold on to forms and bureaucracy because they think it creates certainty, when of course it doesn't. It makes mistakes. And it creates Kafkaesque kind of nightmares when it does create mistakes because it's so inflexible. And people will assume that it's unacceptable to have a system that occasionally, that is statistical, but might actually give the wrong answer occasionally.
Well, the other thing too, and this is very cynical, but I think true, I'm just thinking of that, is forms give power, right? Statistical stuff means you have to, so there's lots of forms in this world where somebody is the gatekeeper, is the key holder or whatever, and is very conscious of that and keen to hold on to. So that comes back to my cold, you're not going to take this form or these forms or this form paradigm out of my cold dead hands, because
but certainly that would be my dream, to see if how many forms could be eliminated from a statistical approach to computers and interfaces. Then it'd be, I think it would make the world much more humane in terms of the way it felt.
But that would almost be, so David, we have to have a side think tank for the social cultural, like that'd be the equivalent in the sort of information industry to, we need to have a plan for coal miners, like, because these are real people with real jobs, all these bureaucrats, and whether they're in private or public, and that's a much bigger population than coal miners, even as coal miners as a metaphor for.
Well, exactly. The machine.
Half the world's like what in France, like half the population works in the civil service, and I'd say, I'll just take a stab at it, half of those would be completely irrelevant without forms.
No, it would be an enormous change to society, but do we really want more people making forms? I mean,
no. So I'm not saying, but I think I'm saying that because if we're, for like, as you think, and coming back to maybe a little bit closer to earth, if you're thinking about building things with this or whatever, I think that oftentimes, and I've learned this as an investor and a builder over the last 20 years, a lot, actually, that was one of my steepest learning curves, is not paying attention to, like sort of dismissing the dinosaurs or the old way, is just like, that's interesting over a beer or a heated conversation. But if you're actually trying to build something and affect change, ignoring that is like a death sentence. It's like, it's just.
No, it's definitely, the assumption for a long time was that the machines, that software was going to automate form filling and things like that. But it wasn't going to eliminate. The assumption was it was going to allow humans to do human things, and then the software would automate all the structured stuff. Now, what we can see in this future is actually the structured stuff goes away and the computers start doing quite human things. And in that sense, you're right. Then there is a huge issue: is what do humans do? The humans do when they look to this point. The reason I'm an optimist there would be when you have an information-driven economy based on computers and the web, etc. You can produce things at scale very cheaply, just like. Ford realized that if he didn't pay his workers enough, they couldn't afford to buy his cars. I think that we'll reach a point in society where if people don't have enough money to consume the things that we can make very cheaply through sophisticated information technology, then the things will collapse or self-correct. We have to create a model where people can consume at scale, because this is, there's no use. You can't create a Louis Vuitton style approach to this stuff, because the economies of scale mean that they have to be mass products, so they have to have mass consumption. So I think it self-regulates at that level.
Yeah, but self-regulates, like, what's the That's a nice hand wavy. What's the path dependency? Because even if you think about the political landscape, or the political ideas landscape right now, wherever you are on the spectrum, they're all fighting the battles of the 20th century, right, of the industrial age. And I think until, and this is where this whole generational thing, this is sort of fascinating, where Carlotta's model kind of breaks down a little bit, because for the first time, for the last 250 years, there was serendipitously or whatever sort of a alignment between the technological paradigm, economic paradigms, and the generational. Basically, short version is people died in a reasonable time span, and today they're not. And so you have the sort of leadership of the world, and so I think for the first time I've read a stat that, like, for the first time over half of Europe's population is over 60 or something like that, or and this is just going to keep expanding to different regions, and eventually at some point this century in the whole world, over half the world population will be over 60, and then over 65 or whatever. And coming back to these cognitive biases that we have, you and me included, like, to do those that kind of shift that you're talking about, I don't, like, as a student of history, I just don't think it can be done in any kind of, like, not extremely violent way, unless you have that sort of generational change where those cognitive biases are different, or like at least more in phase with the. So
I mean, you're right in the sense that there is no free market solution to this. You have to tax the robots or do something like that. You have to create some redistribution of wealth, or to be where I'm going with this is, like, actually, and this is why people like us find it very hard to, and certainly people older than us or less, is actually you need to sort of start from a blank piece of paper, because let's say even if we are, like you and I, are full believers in it, we understand deeply, we think a lot about it, we will still be trapped in, like, these mapping analogies. So like you just said, tax the robots or whatever. Like, I'm not saying that that's wrong, but my instinct as the solution is something that looks completely different. Like, and so you can actually, like, take the existing systems and paradigms and like reinvent one, like, and sort of say, like cars that fly. It's like something completely different, that the known, I think this is something, the known unknowns, right? Nicholas Collin had some good ideas here in terms of, like, what does the modern social pact look like? Because the social pact for the industrial age doesn't apply anymore. We need a new one.
Yes, exactly.
And it's
so maybe we can put that into GPT-3 and they can tell us what it
exactly.
It can tell us what it looks like. What is the new social pact in a world of semantic, ubiquitous semantic compute?
Yeah. Okay, maybe we should end on that then, and chat there. That was a good chat that wandered around quite a few aspects of computing, and I think it's relevant today more than ever.
Yeah, I mean, the way I would wrap it, I mean, we went down a lot of rabbit holes, but that, for me, and sort of looking back, that's become a good tell for something that is important and interesting. And we certainly, there was, for those listening at home, there was no intent to have a definitive conclusion, otherwise to mark the point that this is something worth paying attention to and could be, world changing. And I think finance could be at the vanguard of this, at the risk of self-centering, framing bias or all the rest of it. It actually, beyond the pretty images or creative new images and some of the GPT-3 stuff, because of the non-deterministic probabilistic elements of finance, this some of the first business models might arise in finance.
Paradoxically, accounting is about numbers and deterministic processes in theory. We know in reality it's not. And secondly, we know that all of financial services is about risk, whether it's insurance or banking. Therefore, risk is probabilistic in its nature, and it's at the core of this probabilistic world, ironically, is the most quantitative sector.
Yeah, and there's some, and that exactly where I was going to. There's at least some, coming back, we finished on the cognitive biases and how we're trapped. There's an element, a significant element in finance that is where that leap, that that blue ocean is smaller because they've been working in a world of, in the whole derivatives and capital markets and financial derivatives and modeling world is a world of probabilities. It's not a world of deterministic. So interesting. Good discussion. So everybody check out Dave's tweet stream from today or yesterday, and if you want to get a capsule of the hypothesis that we started poking holes into.
And that day, I think, if you're looking at this, is the 13th of September, 2022.
Yeah.
Super. All right. Thanks, Sean.
Thanks, David. Thanks, everyone.
Thank you.
Take care. Bye.